Okay, to analyze the photo that students took of their repulsive balloons, we're going to insert in Logger Pro a picture with photo analysis, and I have a student's photo here on my USB drive. So here are two balloons being repulsed because they have an electrostatic charge on one another. And I'm going to tell Logger Pro that this is 1 meter from there to there. So I've just set the scale that's 1 meter. And now with this button, we can very accurately measure the distance here, our hypotenuse, and the distance between them, which are the two distances we need. So those are the two distances that we need. So record those. That's your distance of the length of the string, and this is the 2D distance. Okay, so the front page of the lab. I'll go to my ImageMate. Oops, I have to take my USB out and put my ImageMate. There it is. So here are the notes from the front page. The pink show the three forces that are on this right-hand balloon: the electrostatic force, the weight, and the tension. The tension has two components, the Y and the X. The Y tension is the sine because it's adjacent to the angle you'll be able to figure out. And the X tension is actually the opposite to that angle that you'll be able to figure out from our dimensions. So it's the cosine. And the Y tension, this is the horizontal. The X tension and the electrostatic force in the X direction add up to 0. The Y tension and the weight of the balloon add up to 0. So I can rearrange those two equations like that. We could substitute to cancel t. We don't know t, so we got to cancel t. But instead of substituting, I set them as a ratio of the Fe to mg, and that equals the tangent of theta, because sine over cosine theta is tangent theta. So the electrostatic force is equal to the weight of the balloons, of one of the balloons, times the tangent of theta. Once you know the electrostatic force, you can plug that into Coulomb's law. We're going to assume that the Q, the charge of the balloons, are the same. So you're really only going to be solving for a single Q, so it'll be Q squared in the numerator. This R is the distance between the two balloons. So in order to find theta, in order to find theta, you can use some trig to solve for the theta, and then you can use the equation. The Fe is mg tangent of theta to solve for the electrostatic force. Then you can use Coulomb's law to solve for Q. Once you have the charge, the number of coulombs, you can figure out how many electrons, because you know, did I tell you in lecture? I think I did, the number of coulombs of one electron. And that's the lab.